Hey everyone, thanks for coming to my tutorial. In today's tutorial, we're going to be looking at how we can use PCG in Unreal Engine to quickly create environments that we can use for driving plates in-camera visual effects. What am I talking about? Well, this. One of the biggest challenges we hear from small and medium-sized productions when they're trying to utilize in-camera visual effects is that they just don't have the budget and/or skill set to create digital assets for the LED wall. They're relying on studios to create things, but that can be really costly and time-consuming too, especially if the LED facility doesn't have a robust VFX pipeline already set up within their business. Today's tutorial is going to look at PCG in Unreal Engine and how we can utilize it to quickly create environments that are robust, camera-ready, and offer a great amount of dynamic ability for customization. Today's tutorial is going to operate at an intermediate level. If you've never used Unreal Engine before, I recommend you go check out Epic Games' Your First Hour in Unreal Engine. It's a great tutorial and it gets you started out on the right foot. Now, if you spent a little bit of time in the engine, spent some time blueprinting, maybe working on some in-camera visual effects, then this is the place for you. We're going to start with PCG, Procedural Content Generation, and we're going to build from the ground up, seeing just how flexible and powerful these tools can be. We're going to be combining them with the uses of splines, the more traditional spline meshes, as well as using it as path for camera, and create in-camera visual effects imagery, just like what we saw already. If that sounds great to you, well, then let's get started. Thanks, Donna. Let's jump in the engine. All right, so for today's tutorial, we're going to be working in 5.4, and I recommend starting a new project. And from the template, we're going to use the end display template. This ensures that all of our ICVFX and the required virtual production plugins are already set up. We will be able to turn on any of the PCG required plugins pretty easily. So with your end display template selected, choose a place to put your project, name your project, and hit create. I've already done that, so I've got my beautiful, well-loved, well-known end display config. I've also gone ahead and added a couple of assets into this project just so that we can full out our forest. I mean, obviously we're going to need some trees, we're going to need some grass. So I've gone ahead and I've grabbed those things from Megascans or Fab. You can find whatever works for you. If you're able to, you also might want to find a road texture, because we are going to have a road going through our forest. So you can find that on Fab Marketplace via the automotive bridge scene, which is an Unreal Engine or an Epic Game provided Unreal Engine demo project that has a lot of great assets, including a pretty sweet road material and object. So make sure you grab those. You'll have what you need for the tutorial, and then we can get started. So take a second to do that and meet me back here. Now, we're in our project. We don't actually need our template map. So first thing we're going to do is inside of maps, we're going to create a new level, and make sure you go through file and go new level so that we can build from one of these templates as well. And we're going to choose the open world template because the open world template has a landscape as its floor base, and I don't need to say the changes there. That's really important for what we're going to be doing with our project in PCG, because the PCG elements, the nodes we're going to be using, sample the landscape. And so if you don't have a landscape object, if you just have a plane or a mesh acting as your floor, you won't be able to get the results we're trying to get today. Okay, so we've got our wonderfully enormous landscape. Doesn't matter what it looks like, we're just going to deal with it right now. And first thing first that we're going to do is we're going to get into PCG and create our forest. So creating a PCG object is simple. Let's good practice in bookkeeping. We're going to create a PCG folder. And then inside that, we're going to right click, and we're not going to find any of our PCG options because we need to go in and enable the plugins. So inside of plugins, you can just search PCG. And there are many here, but we just need the ones that are in beta. And that will, for the most part, probably in a lot of your exploration into PG, cover what you're going to be doing. Obviously, PCG is a new technology, and Unreal is doing a bunch of cool stuff in investigating it, so it's not on by default, but there's always more stuff coming out. So hit restart, and we're going to have our plugins turned on. Always good to check that. Super. Now when we right click, we have PCG graph instance. That's what we're going to need today. Now my map came back, so I didn't save the other map, so I'm just going to do new level again, open world. And now I'm going to save this current level as level underscore. Let's call this PCG forest. Alright, I'm also just going to take a moment and make that my default project in case we have any crashes or otherwise. Then it's just going to open up in PCG forest as opposed to the main or anything else. Alright, so here we are in our PCG folder. Let's right click and we're going to create a PCG graph. Okay, let's call this PCG and we're going to call it forest. Alright, save that item. And we're going to drag it into our level. Okay, and we notice we have a volume. It behaves and looks like any volume you'd see post-process or light mass. And this is the space that we're going to work in. Alright, now PCG itself doesn't do anything right away, so we actually have to open it up, and that opens up our graph. Now I'm going to operate today in sort of side by side so that we can see what I'm doing in the graph as well as what's happening within our level. So this should probably give us a vantage that we can work with. Obviously you can change the volume to as big or small as you want. I'm just going to go with what's default today. When we're dealing with PCG, there's a lot of fine-tuning, and it can get really finicky if you want to get it just right or to look just great. We're going to avoid as much of that as possible today, because that can be that last 10% of the job that takes 90% of the time. So we're going to really work through just sort of going through the feature set, showing how things work, what you can do with them, and then I leave it to you to explore your creative freedom and make it look really stellar. All right, so inside of our PCG graph, it looks pretty much like any other graph you might be used to while blueprinting, but we have our own new set of tools. So first thing we're going to do, like I said, is we are going to operate in this landscape. Now, we are going to be spawning meshes on this space inside of our volume. And the way that PCG does that is it's going to sample that surface of that landscape, and then it's going to pick out points. And on each point, it's a point where it could spawn an object. So that means if this landscape was more fleshed out, if it was a properly created landscape with its own landscape material, you could not only have objects on a flat plane, you could have hilly plane, you could have PCG react differently to different types of landscape terrain. So there's a lot of functionality and a lot of advanced ability you can dig into PCG, which is why it can sometimes be really intimidating to users that aren't comfortable with blueprinting or more of the game side of things. However, it doesn't take very much to get it going, and you're going to see that. We're going to get 4 nodes onto our graph, and then we're going to start getting a forest. Okay, so first thing we're going to do, we talked about that landscape, so we're going to get that landscape data. So get landscape data. Boom, right there, okay? And from that point, we are going to then drag this off, and we're going to do a surface sample. Okay? All right. Now, even at this point, we can start to see things inside of our volume. But when we look at a volume, actually, we're not seeing, in our PCG, we're not seeing anything. And that's because by default, there's nothing to display there. There's no mesh, there's no otherwise. So when we are working with PCG, sometimes we need to flip into a debug mode. By clicking on any node inside of our graph and clicking D, we can turn on debug. And you see, instantly, now we're seeing how we have sampled within our space. So very simple. Our landscape data has been collected, and we've taken a sample. And within surface sample, we're now defining how many points we want to select. So here we have points per square. This number maxes out at 0.1, so going to 1 won't go any higher. But 0.001 will give you a smaller distribution. So you can play around with distribution at this point. You can also play around with the point extents. Extents are sort of the size of each point. And so if you have larger objects, like we're going to have trees, then you might need to change your extents so that your trees aren't bumping into each other. We're not going to jump too far into this level of detail of changing yet until we get our meshes on the board and we can sort of see what we're actually dealing with. Because right now we have no sense of scale. Looseness allows us to play with the sort of the randomness of the placement of points. We see right now that while, yes, we have some distribution of points, it kind of still looks like a broken grid. If you increase your looseness, lowest value being 1, highest value would be a lot. But if you play with your looseness very quickly, it starts to scatter. But as you scatter things, you have less and less of objects. So probably playing with the 1.5, 2, you sort of get this distribution. Again, not necessary for us right now until we really want to dig into what our forest looks like. And the last thing I'm going to talk about here is seed. Now, if you haven't worked in generative AI or procedurally generative tools before, you might not know what the seed is. But functionally, when we create something using a generative tool, it's not like a linear process. We don't sort of throw something into an algorithm and it starts and it goes to the end. It's more like a cloud, a vacuous space, and you can imagine it spends a certain amount of time in the space and then it pops something out. When we choose a different seed, we choose a different place in that sort of cloud to begin. And so the seed is a starting point, and that's where the randomness, the generation, the calculation starts. So by choosing a different seed, a different starting point, we can vastly change the endpoint. So if we change our seed here from this 76 million object to, say, 200, we just get a different set of our points. Different, you'll notice they're colorized and they're distributed differently. Now you can also go into the minus numbers here. You can go very high. It really doesn't matter where you go. There's no necessary rhyme to reason. Larger numbers don't give you, a predictably more unified form. It just sort of gives you the ability to try some things out until you see something that looks good. Obviously, the more you get into PCG, the more you'll understand what looks good. But for now, it's good to know, and it's really important to understand what seeds are. Okay, so now we might have noticed that all of our meshes right now or our points are very uniformed in directionality. So that's obviously not great for making a really realistic scene where you want things turned around. So I'm going to throw on a transform points node, and that's going to allow us to make changes to our transformation. And like most transformation options, you have your transformations, rotations, scale. You can make all sorts of changes. I'm just going to do my rotational and say you can rotate them any way you want, but you'll notice immediately I don't see any changes happening in the volume. And so I could make all sorts of changes. I could change my min-max offset. Maybe I want that to be 100, and still nothing's happening here. And this is something that's really easy to forget about and get stuck in when you're learning PCG. We are debugging our surface sampler right now, but we're making changes in the transform point node. Signals flow through our graph, and if we are sampling something early on, then we are looking at, we're debugging something early on, we're looking at that node's performance. So any changes we make downstream will not be captured in the effect. So actually, we need to be debugging our transform point. So I hit D on this point, and now we see, some rotations happened. Well, I mean, we're seeing both. So let's undebug that, and now we're seeing a nice distribution of randomized rotations of our points. And this is good. This is going to start, it's already starting to look kind of like a natural distribution of things in the wild, and that's what we're going for here. We want our forest to sort of feel like it's living and breathing, right? So, all right, we've got our points. We're pretty happy with distribution. We've learned a little bit about how to manipulate that. Let's actually make a forest. And so now we're going to assign meshes to that, and we're going to spawn a mesh at each point. So we're going to use our static mesh spawner. All right, and this is pretty self-explanatory. We are able to, similar to a foliage tool, we're able to select more than one type of entry in order to have multiple different types of things. So in our mesh entries over here in our mesh selector, we can create an array of items. Just for the sake of today, I'm going to create 2, so we'll have 2 different types of trees. So first, down into index 0, descriptor, then we get our static mesh selection box. And like I said, I went forward and I got some trees already. Sure wish the, okay, there we go. The previews had come through. Let's get one of these half trees. I'm liking sort of the look of that. Okay, and now right now, since we've selected that there is going to be 2, only half of the points are populated. If we trashed that second one, for example, which I can only remove all of them. All right, I'll just do that. So we'll do one at a time by creating a descriptor and going to our static mesh and getting down to our half spruce. Now we're going to see all of those points populated. When I create a second array element, and I now have a second descriptor with a different mesh, I'll choose a nice full tree. You see I can have now down here 2 types of trees. Now we're starting to see here it's pretty tight, so I think we're going to start playing a little bit with our distribution here. I'm just going to set this view right here as a camera. In case you don't know, a quick tip is any view in our viewport here, if you press Control 1, 2, 3, or 4, you set that viewpoint as a camera. So I'm going to go Control 1, and now I can return to that view. So no matter I get far away, if I press the 1 key, I return to that view. So I'm going to have that nice far away view. Let's just get in nice deep here. I'm going to set a Control 2. So I've got a close view and a far view. All right, so I can go 1, 2, and get back in there. And in 5.4, or maybe 5.3, it actually tells you when you're doing those things, whether you're jumping to the new view or you're setting a new one. That's a new feature. It's nice, a little bit of feedback. Now, our volume here is a little tiny as it is, so we can expand, of course, that, but it's an unusual place. So let's just point out inside of our details panel for our PCG graph, inside of our scene, we have a space called brush settings, and it's here that we make our changes if we want our volume to be larger. So that can be a little bit confusing because you're not necessarily thinking about it like a brush, but that's where we make it bigger. If you try to make changes in using the traditional gizmo, you actually will be warping it. So you'll warp all of the meshes inside of your volume, which could be useful if that's what you're trying to do, but it's important to know how to do what you want to do. So now I've changed this a little bit. I'm just gonna zoom out a little bit, and I'm gonna reset my camera 1, camera 2, probably back out a little bit. There, my cameras are now in better places. Excellent. Okay, so we were just saying, okay, our forest feels a little dense, so I'm jumping back into my PCG graph, and I'm going to change my point extents. So let's try 200 in our XY. That's, I think, a little bit more sparse than I want. Let's see. Imagine you're a car driving by. You want to have a limited enough foliage that you're going to see the parallax of the trees, right? You don't want it to be so dense that you can't see through the forest, but you still want enough that's interesting. I also think at this point the debug is starting to be a little bit distracting, so I'm going to turn that off for now, and just so that we have a little bit of a view here. That's okay. Let's, like I said, we're not going to dig too far into it, but I think I'm actually going to go at 175 because I just want a little bit more treeage. Yeah, I'm feeling a bit about that. Now, it's also a little bit distracting, the material on the ground, the typical checkered. That's just slightly bit distracting too, so we will change that before the end. But before we do that, let's do another round of spawned items, because as you would normally flesh out a forest or a scene, if anything, you're going to have large trees. You're also going to have a lot of shrubbery, some ferns, some bushes. So we can create another collection of objects for inside of our PCG space simply by just duplicating our spawner here, and we're just going to choose different objects. So we can trash these guys, and we can, let's check this out here. So if I'm debugging again, oh, getting some freezing. Oh, yeah. Yeah, when you debug the whole landscape, you see a lot of things, right? So now we don't want these to completely overlap. Oh, I missed a point. That's okay, we'll come back to it. So, okay. So we can, I'll just back that up. So we can do that by recreating or duplicating our whole spawner, and we can just click and drag that down. And making sure that we have a different seed allows us to then create a different collection of things. Now, we aren't going to have those trees, so let's just blow away our original trees. And we're seeing some overlap because we are still in the very large points, right? So we actually are going to go back to our 100s here, and now we're going to see a lot of smaller points, and that's the kind of thing we want to see, that density, if we're going for some ground shrubbery. I might even go a little bit lower. Let's go down to 85. Oh yeah, that's nice. Seeing some serious coverage there, and I'm going to select in my entries here some ground coverage. What do we call them? They were called, they were the ones without these previews. Cotton grass, that's probably what I'm looking for. Of course, I'm getting an error off the Megascan stuff. I'm just going to click fix. Hey, it worked. Well, isn't that great? Okay, so I'm going to click on that one, and I'm probably going to do that same process for another node element. There you go. This video just became how to fix this little weird loading thing from some of your Megascans. Does it automatically. Now, you might be saying, okay, like, we've clicked it, but we can't see anything. It's because our debug's in the way. So let's turn that off. And we still can't see anything. Well, let's get a little closer. Yep, nothing's there. Nothing's happening. So let's check out and see what's happening going on here. I think this is because we had that little error as mentioned. So that's not going to be useful to us. Let's try a different material. Megascans let me down today. So let's try a different mesh. But no, I am frustrated by that. Give me 1 second. Let's jump into this. 3D plants, cotton grass. That is what I wanted. Why? I mean, it's there. It looks happy, but it's not happy. Oh, okay. Goodness. It's there, but it is just minuscule. This is why I didn't turn the grass floor on right away, because that is epically small. And that's partially probably because of our point here. So let's transform this, because I want that distribution. So let's transform this, and let's scale this up. So actually, let's say the min scale is going to be at least 2 times that size. and max is going to be 5 times that size. There we go. Okay, now we're starting to see a little bit of grassage, right? A little bit. It's not quite the effect I want, but like I said, we're not going for perfection here. What I've shown here is that you can depict a range. So in your generation of objects, that you can have smaller and bigger, and you'd want to do that with your trees and everything else as well, just to give that randomness and lose that uniformity. Like we see right now in all of our evergreens, they're all extremely uniformed. Well, same option here. We can go up. Nope, that's the wrong. I said 0.5, 0.5, 0.5, and then 1.5 on our scale for all of our evergreens. And now looking across our forest, we no longer have that feeling of uniformity in those trees. And that does a lot for the realism, okay? And so these grasses are a little less heavy than I wanted. I probably wanted something a little bit more significant. But I'm not going to spend too much time going through that again. Like a nice fern or something would give the coverage I want, but we're not going to go forward that. We will then not worry about it, but we'll talk about how right now sometimes these objects are getting really close. Now it's less of a problem. It actually kind of looks okay. Oh, there you go. They're getting a little too close. They're starting to impinge on each other. If the grasses were more visible, that would be a problem. Because you don't want your objects smashing into each other and then just passing through each other, because there's no physics in them. They're just going to not touch. They're just going to, mesh. So we can make use of the difference node to control that. Now, when we're working through some things and we're trying to see exactly what we're doing, sometimes it's easier to disable nodes so that we can just see what we're dealing with here. So that's just a little quick tip there, that you can disable a node if necessary, and I think due to the grass I won't have to, the smallness of the grass I won't have to. But let's add a difference node into our chain here, so that we don't spawn grass where there's already a tree. All right, so we're going to drag off this and go to difference. Okay. And we're going to remove this point. And those who don't know Blueprint graph very well, if you hold Control, you can move it off of a point, or if you hold Alt, you will get rid of that connection. So I'm going to hold Alt and get rid of that. So our difference node is going to say, okay, where there is a source and a difference, that's how we're going to determine the transform. Now I immediately already have 2 transforms here. That's a problem as well. So that's why we suddenly saw all the trees, because we were having both the real and the not real, and actually that should go to that. That's why we saw all the trees forever. This way we're only then going to see trees and grass where they don't conflict. And if we want to just disable these guys for a second and then debug these, we'll see that while the sizing is overlapping, they're not occupying the exact same space. All right. And actually here, this is really nice. We're seeing that distribution of size very nicely right there. So we have used our difference node here to calculate and say only post ferns, or the lower things, where there isn't already a tree, and that's where we go to that. It's important that we still don't actually do anything different to our trees. I'm going to press E to turn my trees back on, and that way we only get our lower ferns where there aren't already trees. And this is obviously good for realism. You don't want items passing through each other, but also it's wasted resources if you just start doing all these tiny little grasses and you can't see them because they're half in a tree. It's no good for nothing. All right, so we have a forest. We're missing a floor, so let's just really quickly, and I'm hoping Megascans doesn't Doesn't fail me again. I'm going to just really quickly pick a section of this landscape and find where I can add a landscape material here. So we're going to pick our mossy forest floor. That'll do. Drag that out there. That didn't work as wanted. Why not? Drag that out there. Didn't work. Because you have to turn it on. Floor. Let's multiple click them. All right. And now let's see, if we run down our camera 2, hey, it's starting to look a little bit better. Now, the tiling on that's not very good, so let's jump right into our material instance for a second. If you're not familiar with how to fix tiling, so we're seeing this patterning on our floor. It's because we've applied this material that's quite dense, quite small in a very high density, but this material has a lot more information in it than that, so we can open that up and get rid of that tiled feeling, and inside of the material instance, that's going to be inside of global parameters, tiling offset, and then we can choose our tiling. So I always start by going to 10x 10y and seeing how that looks, and sorry, that's the wrong direction. 0.1 and 0.1 is 10%, and immediately you start to see it getting way better. We still see some tiling. In the forest, it's starting to look good. Let's go 0.15 and 0.15. That's looking really good, especially when we start to get down to ground level. Like we remember we're going to be coming through, and this is nice, our grasses are sort of visible here. So we're going to be coming through sideways in a driving shot, and that looks pretty good. You know, we don't have to necessarily worry about the tiling when we're this close. And this is why we tile, because at different distances, it's going to look better, and so that's enough. We don't want to spread it too thinly. Just for a point of knowledge here, if like say I went to like 0.01 and like 0.01, I think you can already see right there. So that starts to really stretch that out, and it doesn't look very good when you get real close, right? It starts to look very much like a picture, a texture that's just overblown. So that's why it's just about balance. And usually this is going to be where this looks kind of like what it would look like if I was standing there close to that bit of earth. Okay, now we're seeing obviously our LODs come into here, our shadow culling, and our billboards. We're not going to worry about that kind of stuff because, again, once we actually get going, we're going to be inside of our level, so we're not going to worry too much. We have a forest here. Looks pretty good, looks good from ground level, which is really what matters, right? Really, this sideways profiling is what we're looking for our LED wall. So let's add a road, okay? And we're going to do that using a spline. Now, if you've never used a spline before, it really is just a line that you can build and curve and align. And splines are really functional, and so we're actually going to be using our spline a lot today. But for this PCG usage, we're just going to create a very simple blueprint. Okay, it's an actor blueprint, and we're going to call it BP spline. All right, save that and double click into that and open up our spline object. And we're going to add a component spline. And we're going to make sure we're doing a spline and not a spline mesh. We will be using spline mesh later inside of our graphs, but spline mesh is for when you want to be able to warp a mesh. We right now just want a line. And you can see we have this line. And if you've ever used any of the sort of drawing tools in Illustrator or Premiere, you may have seen lines like this before. When you click on them, you get handles and anchors. I'm also going to add a billboard because splines are very tiny objects in your level, and they can be pretty hard to click on. So a little billboard will help us see it and click it. So click on that, click save. We have a spline. Let's drag it into our level, and I'm going to drag it over here. Okay? And if I zoom in on it, and this is our spline, I'm going to set this camera location 3. You can see it is exactly what's promised. It's a line with 2 points. If we click on the second point, we get our gizmo, and this then allows us to make our spline bigger. So if I've clicked on my second point, I can then drag that all the way across our forest, right? Okay. And then you'll see I have my, I think they're called bevelers or bevels, and I can click on those, and then I can use that to curve my spline. Now I can also click anywhere, right-click anywhere on my spline, and I can add a spline point there, and then I can move that point as well. So now I can also change the directions and the weighting based on that type of thing. Now the challenge of splines in Unreal, and the thing that is usually the gotcha for people, is you'll want to click on a thing and then immediately drag it. But you have to play within the gizmo rules of Unreal. So you always have to click on the thing you want to move and then move it accordingly. Okay, so just something to remember while you're doing it, because if you just click and drag and then nothing's going to happen the way you want it to do. All right, so we've got this spline, and this spline represents our road. So what we want to tell our PCG system, excuse me, what we want to tell our PCG system to do is to say, anywhere there is this spline, I don't want trees. Right? That's what a road does. It cuts through a forest. So we need to cut through our forest. So let's jump back over here into our forest graph, and we are going to now get spline data. Okay? And we're going to do a spline sample. So now we have a spline sampler. And just like, before we do anything, we can then select our spline, but you have to actually go through a couple settings here. So when collected on get spline data, this graph is looking for itself, but we actually want it to look at all world actors, and then we're going to identify which one, because right now it's just looking at all the splines. It's looking for a spline. We want to say, okay, well, by class, find the spline that we call BP underscore spline, right? That's us. Spline mesh drawing is a default. So now we have identified our spline, and it is now going to be sampling our spline through the scene. And if we debug that, it might show up. No, not sure. Okay. All right. And now we are going to look at that and think to ourselves, it's going pretty good, but it's not doing anything yet, because we need to say, well, don't draw where there is something, and we did that before with our difference node, so we're going to do that again with another difference node. And rather than creating it in our spline here, we're going to add a difference node to our first thing, and I'm going to hold Alt here, kill that, and just say okay. It's all right. And we're going to say, well, wherever there is a spline, don't do that, right? So we've just added it to our existing node graph, and now we've just added this extra element. And if we look at it, nothing really happens. Well, it's because right now our spline is super thin. And I almost explained this before I explained the other part, which is why I got a little lost my mind there. Would have made no sense. It's because a spline is 1 centimeter by 1 centimeter by default. So obviously, it's not going to be hitting too many things. And in the case of our work, a road is not 1 centimeter by 1 centimeter. So we can change that by adding an extends modifier into our spline sampler here. So we're going to go extends, okay. And this is actually what we're going to difference instead. So actually I'm just going to kill all those, and I'm going to go there, and then I'm going to difference, and I'm going to diff those. Let's pull that back, clear. And inside of our diff, we can change our x, y, z. Now, I'm going to change all of these to pretty significant. Let's see, so we can start to see some numbers getting cut off. All right, so we're starting to see some stuff there. Our x's are forward in the spline, so actually the x really doesn't have an effect. You can leave that at 1. It doesn't have the effect we want. You notice that I made that change there. So like imagine you're adding, oh actually that's probably, we can debug. Imagine you're adding, exactly, spaces here. So this is how we are addressing our spline here. So we want it to look like blocks. So perfect. 200, okay, so that is the one we want. Except we want that to be a little longer. Which one's this one? 400. It's looking all right. Notice how we're seeing them just sort of along the points, but not all along the spline. It's sort of just at these random junctures. It's because we need to set our mode to multiply. Okay? And this is why we don't want anything in our x. Okay? Now we start to see how the shape is forming along our spline. Okay? So let's see. Just seeing what I had in my. I like that one kind of wide. Does a pretty good job of clearing. So let's take off our debug, and there we start. We have a pretty nice clearing. It gets a little funky at the end there. Maybe make that a little bit. Maybe make this 500. Yep, gets rid of those trees at the end. All right, and so you can see that we have a clearing. Now, why have we gone to all this effort? Like, we could very easily have just drawn a road and then created a gap in the woods. Well, the great thing about PCG is that it's real-time procedurally generated. So if we want to make changes, I can change the shape of my road, and then my volume is going to change as it goes. Okay? And this is the valuable stuff. When we're always talking in virtual production about being able to do things quickly. Well, how quickly were we able to create a forest? Were we able to create a path through that forest? And now we have complete ability to change that however we want. So if we wanted that to be a nice S-curve, and I'm going to leave the S-curve. I like the S-curve. It's kind of easy to see. And it's like that, and it makes changes, okay? And if you take the time to really go through your graph to get the density of the forest right, if you make sure that you create your landscape so it looks very realistic, you can really dig in and have a really functional as well as reactive and very dynamic level. If you're looking at your landscapes and you press the A key, we can look at different attributes of our landscape. And you'll see here on the right steepness. So our ground is flat, so there's not steepness. But the more built out your landscapes are, so if you've established things like muddy and water and different types of areas that will fall under different type of textures, then you'll see all of that type of information in here. And that landscape data, being that it is accessible and readable in our PCG graph, are things that you can react to. So you can say, all right, if something is a certain steepness, don't do a tree. If something is water, because that's pretty common in your landscape, don't build a tree. So you could have a completely reactive landscape that reacts to the changes you make by like moving a spline that represents a river, or in our case, the road. And that's the power of this. It's very quick once you sort of learn and sort of set up these samples. And I imagine if you were a studio and you were doing a lot of this sort of work, you could probably get pretty quick at developing the content, and it's all custom content. So that is our PCG forest. That is part 1 of our tutorial. Now we're gonna talk about we're gonna finish this spline and make it a road. And this is something it's been done for a long time. I'm gonna just save all my assets here. I'm gonna be making this spline into a spline mesh. or rather I'm adding a spline mesh to the spline. So anywhere that this line goes, I will have my road object, my road static mesh, following that path. Now there's lots of tutorials out there that show you how to do this. I'm just going to show you one method, and there are multiple methods. Like I said, I grabbed that piece of road from the automotive sample because I needed a static mesh. So just find a static mesh of road, or you could even do a dirt path if you want to do like a walking trail, or you could do a little, you could try water if you want to get a little ambitious, see how water works out. Feel free to experiment. You don't have to do exactly what I'm doing. Okay. But when we are building out a spline for a continuous mesh, we need to do two things. We need to set up a loop that will repeat the drawing or the placing of the static mesh at each appropriate point along the spline. So that's based on how long the spline is and how long the mesh is. And then we need to actually insert the object at those points along the spline. Okay. And we're going to be doing this in the construction script. So when you create the spline or you move the spline, it will do these functions. If you're not familiar, the construction script is a blueprint that runs whenever an object is moved, manipulated, created. So it will recreate or redraw our spline whenever we move our road through our forest, which works really well in PCG. So we're in our construction script, and we need to figure out two things. We need to figure out how long the spline is, and then how many times our mesh is going to fit on that. So to do that, we need to find out how big the mesh is and how big the spline is. So we already have access to the spline component inside of our blueprint. So let's drag this in, and we're going to be getting spline, and we're going to get spline length. Okay. That's easy enough. But how do we get the length of the mesh? And that's actually kind of difficult. So the easiest, quickest way I'm going to do it just today is I'm actually just going to look at that mesh, look at the asphalt, and just double click into it, and okay, our size is approximately 3376. Perfect. That's all we need. It doesn't have to be exact. You can play around with the numbers later. And I'm just going to point out this mesh is actually totally not perfect for this application because it has built in a crack. Just like you would in a real bridge, you would have cracks for expansion and shrinkage. And that's going to show forest floor later. So if you're wondering why that's there, that's just because of the mesh. You could take this into Blender and just join those up if you wanted to get rid of that, or come up with a million other solutions. But that's outside the scope of this. So we know that our mesh length is 3376. We need to create a variable to hold that. So that's going to be a, it's an integer. We can totally call that an integer. Let's call that, go up to the right here. I'm going to call that our mesh length. Okay. All right, and so first thing out here, we're going to want to set our mesh length. Actually, you know what? We don't need to do that. If I compile and save, that mesh length, we can set its default bound to 3376. That was something I did the first time I built out this blueprint, but I thought better of it. This way, we aren't wasting a operation every single time we run this construction script. Before, I was going to say, okay, set the thing to the length of it, but it's a default value, so it's not going to change. So we can just set that as the default, and now we can just get our mesh length. Okay, and so something just to remember, those who don't blueprint that often, when you create a new variable, you have to save and compile before you have access to the default value option in your details panel. So it wasn't there until I hit save compile. So mesh length, we can get that. We just got that. We can then do a division. So we're going to take the length of our spline and we're going to divide that by the length of our mesh. Okay? That is going to tell us how many times the mesh will fit on a spline, but it will also give us a decimal number, which we don't want because we want to calculate how many times we have to do this for our loop. And a loop can only operate in integer number of times. So I'm just going to truncate that, which means taking that number, that division, and just stopping it at the decimal point. So if it was 7.7, it's just going to return 7. And that I can use in my for loop. All right, so first index is 0, last index is going to be that. Okay, so that's our for loop. Now, every time we loop, we're going to want to add a mesh to the spline. Okay, so we're going to add spline mesh, and this allows the mesh itself to be shaped and to conform to the spline. You saw the static mesh previously. It was a piece of asphalt. It's a square, but this will then allow, since by making it a spline mesh, it will be able, the Unreal will be able to shape it accordingly. We need to also set about our mesh the sorry, lost my train of thought. We have to actually set the static mesh, which mesh we're adding, to that static mesh, spline mesh component. So we need to set our static mesh. And this is where we're going to pick our asphalt. All right. Now we need to do a return here so that our static mesh is going to the mesh component that we're adding. And then we also need to make sure that the mesh is facing in the right direction. So if I was just to compile this already, you'll see over here the road just sort of goes at a random direction. Now, it's not very long yet because we haven't finished the coding. It's squished, that's why it looks so funny. But it's picked just straight like this, right? And that's actually convenient because we actually want it to go in that direction. That is because our mesh here has a forward X. Okay, and that's probably what we're seeing there. It's hard to tell because it's so squished. But it's always good to then identify so that we don't end up with a double wide road. We want a long road. We're going to set the forward axis. And sometimes this one gives me a problem. So just because we haven't finished identifying some elements, it didn't want to show up in context sensitive, so I had to turn off context sensitive. If you're not used to blueprinting, Unreal does its best to figure out which nodes can follow, but that's not always accurate. So sometimes if you know what you want and you don't see it, you have to turn that checkbox off. And we're going to say our forward is X just to make sure there's no mistakes made there. Okay, so we have identified how long to loop by establishing how many times our mesh is going to fit inside of the spline. And now for each instance, so each time that loop, so say it's going to fit 4 times, so 4 times we're going to add a spline mesh component. We're going to say it's this static mesh, and we're going to make sure it's forward facing. Boom, part 1 done. Now we actually have to insert the segments at the right points along the spline. Okay, so ultimately, what are we trying to do? We're going to work backwards a little bit here. Well, we're going to set the start of where to start drawing, rendering that mesh on the spline. So we pull it from here, and we're going to set our start and end. Okay, and so this is going to say on the target spline mesh component, where does it start and where does it end? And so we've calculated, okay, it has to happen for 4 times. we know how long each object, or we know how long our object is, we know how long our spline is, so we can use those things to calculate the starting position and thus ending position of each segment of our mesh. All right, just takes a little bit of math. So we're going to give ourselves a little bit of space here because we're going to need a little bit. But let's see, what is required here? Well, we need to target our spline. So first things first, let's just pull out our target and just get spline. We'll just keep that nice and neat. Didn't like that. You know, it's probably got to come out of here. There it is. Right, because this is a spline and it's waiting for a spline mesh component. So just excuse that very long noodle, but it's passing actually through all the right places anyways. All right, and so to our start point here, it's looking for vectors. That's indicated by the yellow. So we can, on a spline, we can get our distance at a given point. So let's do that. Let's get location at distance, okay, along the spline. So this is where we're going to identify exactly where on the spline we're going to go. And conveniently, it comes with our spline. We need that target. But how are we going to calculate the distance? Well, we know how long the mesh is, right? So if we pull this out, we can get our mesh length. And so then we just need to figure out at what loop we're at, right? Because if it's loop 0, we start at 0. And when we can figure that out because we have a index here for our for loop, right? So I'm actually just going to put that in a variable. Let's create a new variable, and I'm going to call that at index. So that'll tell us at what loop we're at, okay? And so we're going to make some space here because actually we're going to set, oh, actually no, drag it out this way. Drag it out this way, and I'm going to set at index to this, and then we'll go back into our blueprint, okay? Now we can pull out a third thing here, and now we're pulling out our index. So we just need to do a little bit of math and say, okay, mesh length times however many indexes we're at, well, that's going to be the distance, okay? And that's going to convert that into from an integer to a float. And that's perfect. So the first 0 index, then it starts at 0. At 1, well, then it's going to start at 3, 3, 7, 6. Great. Okay? That's our direction. All right? Next thing we need to do is also get the tangent. Like I said, meshes can warp, but we need to know what is straight relative to the line. So we can get tangent, if I spell it right, tangent at distance along spline. Okay? We don't need that. We can just put a redirect here, and pull off there. Okay. And it's going to be at the same place, so we're just going to drag our distance there. And boom, we have our start. And we also have our, we also have our starting tangent. However, with the tangent, we have to be careful that we're not going to go out of bounds. So we're going to actually clamp this vector just so that we don't draw something that's out of our bounds. And the max is going to be our mesh length. So we make sure that we don't go out of our own bounds here, just as a check. Okay. Okay. So we've got our starting point. Now to do the end point, it's the exact same thing. We just need to add 1 to our index, right? So we can actually duplicate this whole thing, drag it down here, and both times we are going to add 1 to our index and do all the same stuff again. So our spline still goes to the same spot, and our distance is going to be index add 1. Okay, so we're going to add 1 to that. And now we're going to do the same multiply that we did here. So we're going to multiply. So we're going to go max length times integer plus 1, and that's going to feed distance here and here. All right. Okay, so now we have the next, so what would be the start of the next one, which is the finish of the current one, and we're going to put that into our end position, and then we're going to put that, into our end position. All right. So a little bit of noodly here. I'm not going to worry about cleaning up. And everybody's all about redirectors these days. Not going to throw any of those in, either in my PCG here, where we definitely could. Just because redirectors make it a little bit harder to sort of see what's going on when you're trying to learn through something. So I'm just going to leave everything here. It's a little bit, like I said, messy, but just I hope we're not going to waste the time on that. So if I compile that and I save that, bam, what do we have? But we have a procedurally generated road carving through the woods. Gosh, it's a thing of beauty. And if I move it over here, whoop, the trees reform. Move it over here. Looks great. All right. And quick and easy. And obviously you have to massage a little bit. There's a few trees here and there inside of everything. But that's just, playing with the settings and getting it right. All right. So that's part 2. So that's creating PCG forest, using a spline to cut a path. And now we've used that same spline. We've created a spline mesh that can live on the side of that road. Another great way to use a spline is as a path for a camera. If you've ever seen any camera movement in any cinematic in any game, almost certainly it's following a spline path to give you that nice, dynamic, and smooth camera work. So we're going to use that same sort of idea, except instead of using a camera, we're going to be moving our NDC through space in our level. So it's pretty simple of a blueprint, but we're going to this time jump into our event graph, and it's going to be on event begin play. So this will just mean it's going to go starting as soon as the level starts. It's just going to go. I'm going to set it to loop, and we're just going to make it loop. And we're going to utilize a timeline to do this. So if we drag out of our event play and search timeline, down at the bottom we can add a timeline. And then we're just going to double click into this, and it opens up our timeline track graph. Excuse me. So let's create a new track. It's going to be a float track. We're going to give it a 10-second length just to start out. And what the timeline allows us to do in this instance is set the value over time of this float we've just created. We're going to rename this, and we're just going to call this timeline position. So that'll tell us in the 10 seconds what the value is between 0 and 1. And that allows us to move through the length of the spline, because we're going to say, at 5 seconds, it's going to be 50.5 or 50% the way through the spline. So it'll be at location 0.5 on the spline. So we create this using keyframes. So if I click over here, I can add a keyframe. I'm going to add it at 0. Double click into that. 0, tab 0. Give me some trouble here. 0, thank you. 0, 0. Then we're going to go all the way over to 10 seconds. At 1, we're going to add another keyframe. That was by right-clicking. And that's going to be at time 10, value 1. Okay. So now we're also going to tell it to loop. And when we hit play, it's just going to play through in 10 seconds, counting from 0 to 1. All right. So that's all we need from our timeline there to get us started. So in our event graph, here we are. Now, what are we going to be doing while we are actually trying to move along the spline? Well, we're going to be setting a transform, a world transform for an actor. So we're going to work backwards a little bit on this one, but I'm going to drag out from here, and I'm going to do a set world transform. Okay. It's going to ultimately be a static mesh component. So we might actually have to change that as we go. But let me just open this up for a second. Static transform for a scene component. That should work. Oh, that's an interface. Gosh, I hate it when I do this. All right, I just gotta say. Let's do a restart there. So we've got our timeline. And now what are we going to do across that timeline? We're going to actually move an object across space and time. Now, you could pretty much put any object into your scene here, but I'm going to use an empty actor, and I'm going to just use that as an origin point for anything we want to parent to that object to move. It's just a little bit easier, and it prevents us from losing access to details within different components. So in my variables, I'm going to create something called the origin point, and this is going to be of an object type, and actually it's going to be an actor. So let's just do a search. So it's going to be an actor. Object reference. I'm going to set that it's open. Public, I believe. Yes, and so that means you can see it at any point in time. It also means that if I'm in my level here and I create an actor, that I can then what's that, actor 2, let's rename this. We're going to call this origin actor point. Okay. And now I can say, okay, in my BP spline I can set my origin point, and I can say, okay, use the origin actor point, right? And that's going to actually save me a bit of time later. So I'm just going to zero that out so it sits on the blueprint. All right. That doesn't matter what I just did. It'll come in later. Okay, so now we have our origin point, all right? And what are we going to be doing inside of our blueprint? We're going to be setting the transform of this in the world. So we're going to set world transform. Let's turn on constant sensitive so we get the right transformation. Offset. Not feeling great about that. Some days, man, some days. So we're going to be setting our transform, set world transform. Sorry, let me check my notes. I have a scene component, okay? So we're going to set our world transform of a scene component. So I'm just going to open up my context. I'm kind of working ahead here. Yeah, there, that's what we need. Okay, I'm working ahead here just because I know where we're trying to get. Because we have to work backwards. Because in our timeline, we want to, when we update our timeline, we want to set our component. That's simple, right? Along the timeline, move the origin, the object we're trying to move. And that's what we're doing right here. But we have to provide it with this new transformation. And this is why I like to work backwards, so we can sort of better understand what we're doing. The orange indicates that we're looking for a transform. And a transform is made up by a location and a rotation. So we know we're going to have to make a transform. So hold on. Let's make a transform. And we see it's location, rotation, and scale. But we're not going to be messing with scale. So now we just need to calculate the location. I'm just going to space these things out because you can guess we're probably going to need a little bit of room. So let's figure out how we find the location of our object. Now we're trying to move along a spline. So what are we going to do? Of course, we're going to need our spline. All right, so let's drag out our spline. We'll get spline. And just like before, we're going to get location at distance along spline. And the distance this time is going to be filled by our timeline position. But as I mentioned, our timeline position is just going from 0 to 1. So we have to multiply that against the length of the spline. So if we get our spline length, we can then do a multiply. And if we take our timeline position, a number between 0 and 1, multiply that against the length of the spline, we feed that to our distance. So that'll say at halfway through our timeline, at the 5-second mark, it's 0.5 of the distance of the spline. So it takes 0.5, multiplies it times the spline length, and gives you a position at the middle of the spline. Okay. We also need to get our rotation, right? That's just like getting the tangent, except this time we want the camera to follow the pathway. So we're going to get the rotation of the rotation at the distance along a spline. The spline is the same, and so is that moment in time. Okay, pretty simple. So now we have established a location as well as a rotation, and that's all you need, because scale defaults to 1, 1, 1, to create that transform and to set that transform. All right, so let's do a save and compile here. Right. And now, in our scene, we need to put something into that origin actor. Now, I talked about, what are we doing? An end display. So let's pull an end display in here. So this is the template. So we actually should have, sorry, I'm just going to turn off my filters. We should have, I said turn off, should probably clear the search query too. Some example configs, okay? And so let's just go to let's take a look at this one. Curved wall. Oh, many walls. Don't want to do that. We're just going to do a real basic. We're going to grab that basic end display. We're just going to make it a little bit bigger. Now, I'm assuming you've worked a little bit in end display configs before. If you haven't, an end display functionally is it's like a blueprint that contains certain implied information, but the most important part right now is that we have a screen here. Okay, so we can expand our screen a little bit. Right now it's pretty small, so let's make this, that was 200, let's make it 400, not 1,000, 400, let's make it, we'll just make it a really sort of weird proportion, just so we can see it pretty clearly. No, that's super weird, don't do that. What, it should be 1920 by 1080, right? Let's do that. Boom. Giant HD screen. It's going to be way too big. Let's divide those numbers by 2. Am I talking about the finickiness? Alright, this just at least gives us an aspect ratio that would probably work on your screen if that's what you're doing. But we're not going over that detail stuff in this. So perfect, we've got our little screen here. It's already set up for us with a cluster and everything else, so we don't have to spend time doing that. Let's just do a save. And now into our scene, we can drag our basic screen in, and we are going to find that origin actor point, and we're going to say, okay, end display, I want you to be parented to that. Now we want to make sure we clear any of the transformations that happen there. So our end display screen now is just sitting right on top of that origin point, and that origin point is the thing that we are moving across our timeline. We can check that by checking in on our BP spline, which is hiding somewhere. BP spline in our details panel here. Actually, I can expand this a little side. Oop. There we go. In our origin point here, we are choosing that origin actor point. So we should show the origin actor point. Okay, so we're feeling good about that. So now when we hit play, hit save everything, we should see movement of our end display. And of course I forgot to delete the player start. So if that happened to you, find your player start in your outliner, delete it, maybe go back to camera 1. I'm going to set this as new camera 1. All right, and hit play, save, and play, and we can't see anything. This is expected. Interestingly, in 5.4, Epic fixed probably what was a bug, where you would be able, when playing in editor, you could see your end display, but it wouldn't render anything. It would just be a gray screen. If you were using an end display in another application where you were not playing in editor, but you were actually playing like a compiled program, you wouldn't see anything. So clearly, what it appears is by design, you're not supposed to be able to see an end display config inside of the edit or inside of a playing editor, even if you say turn on visibility or turn off actor hidden in game. And obviously, you can understand why you would want that. You never want to see the screen of an end display because it's supposed to be a screen in the real world. Just for our purposes today, it's a little cumbersome. So there's a little tiny workaround that I like to do. And it's just using a simple geometry piece of a cone. And we can throw a cone object into our end display. So I'm just going to bring that in there. Oh, what am I doing? Sorry, we have to first take our cone and put it also into the origin. Now it's mad because its mobility is set off. So we turn its mobility to movable, and now we can put it in our actor origin point. Let's just clear all of those transformations, and I'm going to do this. I'm going to move it slightly behind the screen, and I'm going to rotate it 90 degrees. And the reason I've done that is because, as you see here, you can't see an end display from the back. It's a single-sided object. So by doing this, we establish what direction the screen is facing, because you might need to change that given what pathway you want your car to travel. If you want your car to travel forward, the screen has to face one way. If you want it to be traveling sideways, if you want it to be like a side angle camera shot, it has to travel a different way. So the cone here is a little helpful tool to point in the direction, and then I like to just warp it a whole bunch so that it's very clear which way it's going. But it also should be behind the screen. And strictly speaking, you're probably best off to make sure that this is also hidden in game later, once we're done testing, right? So let's see. Now if we hit play, it's moving, but it's offset. All right. Okay, we're almost there. Something's a little shaky. So why is our location here being so weird? Target is a spline component. These need to be world space. Found it, I think, probably. All right, let's hit play. Boom, nailed it. All right. So it's really important when we're dealing with moving things through the world that they are in a world space. And there we have it. So we have our end display screen moving through our spline, following the line, but I talked about the cone facing a certain direction. Well, this would be great if we were driving backwards, right? Because if you imagine that's the screen, then this is going backwards through the woods. Let's try and make it so it's just like our demo project that I showed you earlier. So I'm just going to kill that. And we're going to add a node in here that actually gives us the ability to make rotations as we need. So inside of our get rotation along the spline node, we're just going to make a rotation. Now, our rotation right now is currently combined, so let's break the break the link first. So alt that, and then we're going to split this pin, and we are going to give the Z the ability to move, because we just need the screen to rotate in the Z. So we just bring this out here, and we are going to give it a minus or a plus. Let's call it a plus. So we're just going to add a number, and then we're going to remake our rotation. So this is going to be a make rotation. Make rotator. All right. And so that's our Z. That's our pitch, and our roll do not change. But we can then change our Z, whatever we want. So I'm going to change it by 90, do a compile and a save, and then let's see what happens. It stopped rotating sideways. That's not what's supposed to happen. Give me 1 second. I forgot to connect that pin. So I'm going to do that. After I've made my rotator, I'm going to then collect. So Z changes, connect to our Z, and then I need to just return that to the transformation, compile and save, hit play. There we go. And now we would see a great shot on our screen for the passenger seat, or like we had it earlier, 270. Save, compile. Shot moving left to right out the driver's window. Okay, so let's see what happens if we then package this and put it up on the wall. And there you have it. A relatively quick and inexpensive driving plate made in Unreal Engine utilizing PCG as well as splines to create something that is quickly made up but infinitely customizable. Hopefully this has given you a chance to explore some of the PCG tools. Hopefully it's made it a little bit more available to you. And I hope that this tutorial will allow you to explore more interesting applications of real-time rendering for your ICVFX workflow. I'm James Rowan. Thanks so much.